So the first dynamic oligopoly model that we're going to do here in Chapter 11 is the Stackelberg model. And the Stackelberg model is really similar to a Cournot model, except we have a leading firm and a following firm. And so sometimes it's called the leader-follower model. But basically what's going to happen is that the leading firm is going to announce its output, and then the following firm is going to announce its output. But they have to take into account the strategic options of each other in order to maximize their profits given the game. And so this is relevant especially for industries that have, a dominant or leading firm like General Motors was in the 1960s, and that, a company like Anheuser-Busch might be in the domestic beer market now. So it's very similar to the Cournot setup, right? We've got two firms, firms 1 and 2. Firm I chooses a non-negative value of output, QI. Firm 1 chooses first in the first period. Firm 2 chooses in the second period. And then they produce, and so we still have one price. And profits are really similar. So it's just AQI minus BQI squared minus BQI-QJ minus CQI. Information is perfect and complete. So Firm 1 knows Firm's 2 profit function, Firm 2 knows Firm 1's profit function, and that's how we're going to solve it. Now, because it's sequential, we have to solve it backwards, right, to find the subgame perfect Nash equilibrium. So Firm 2's problem is pretty simple, right? So it's going to say, all right, for whatever value of Q1, I'm going to find the value of Q2 that maximizes my profit. Firm 1's problem is a little bit more complex because it needs to figure out Firm 2's optimal amount and then plug it into its profit function in order to maximize its profit. So Firm 2's best response function is really just the same as it was in Chapter 10, right? It's going to be A minus C over 2B minus 1/2 Q1. Firm 1 can calculate that, so Firm 1 says, okay, that's Firm 2's best response function or best reply function. And we're going to use that to solve our profit maximization problem, right? So it takes the profit function, A minus BQ1 minus BQ2 BR minus C all times Q1, and plugs in the value for Q2 BR. And so we get A minus BQ1 minus C over 2 times Q1. And that's pretty easy, right? It's linear in all the terms except this middle term. That's just a quadratic. And so taking the derivative, we find the first order condition, A minus 2B Q1 minus C over 2 equals 0. And so Firm 1 is going to produce A minus C over 2B. We're going to plug that back into Firm 2's best response function, and they're going to produce A minus C over 4B. So note that Firm 1 produces more than Firm 2. Price, we still have the law of one price, right? It's still homogeneous goods, so the prices are the same. So that's A plus 3C over 4. Firm 1, in this case, earns higher profit than Firm 2, right? They're producing more and costs are the same. Their profits are A minus C squared over 8B, and Firm 2's profits are A minus C squared over 16B. So it's only half as much. So in this case, there's a clear first mover advantage, right? With the Firm 1, the leader, earning twice the profit and producing twice the output of the follower. Now, in the next video, we're going to look at a Bertrand type game, and we'll see that that is not always the case, that the leader has an advantage. So if we compare the Stackelberg equilibrium with the static Cournot equilibrium, the static Cournot equilibrium would be here at point B, where they produce the same amount. But now, Firm 1 is going to be producing more, Firm 2 is going to be producing less, and moving from point B to point A is not a Pareto move, right? And so it's not that they're both doing better off. Firm 1 is doing better than they would at point B, but Firm 2 is doing worse. And it's not in that shaded area, which is that sort of collusive area where they both earn higher profits and they move towards the monopoly output. So in this case, there's a first mover advantage, but as we'll see in the next video, that's not always true.